In this video, you're going to see me f***ing up this Bambu Lab to replace the electronics from the Bambu Lab X1C with a generic BigTreeTech board. In January 2025, Bambu Lab announced an update introducing the new
authorization control system.
I got the idea of modifying that printer after watching Louis Rossmann's video about this update.
Who the fuck are you to tell me what I'm authorized to do with my own fucking printer?
And this has brought up a lot of controversy within the 3D printing community. In 3D printing culture, this is considered a dick move. This channel is about 3D printing experimentation. I've been doing this since 2019. I've modded several 3D printers. I won a modification masters contest and I turned some everyday objects into 3D printers. Don't get me wrong, this X1C is a good printer, but I'm not depending on it. And considering the situation, I almost feel like it's my duty to modify the crap out of this thing. So whatever your reasons are, standing by your principles, plain curiosity, or just watching the world burn, this is gonna be fun. Okay, before I'm going to completely modify this printer, I've got a fun idea that I want to try first, that I think that some of you can really benefit from. Have you ever tried to replace the nozzle? I don't like the process. You replace the whole unit, so you have to replace the heater cartridge and you have to fiddle around with cooling paste, and it's finicky. It's way different than it used to be with the standard and the printers where you can just replace the nozzle by screwing in the nozzle. So I think I found a pretty fun, easy and very cheap solution, standard, cheap, and the 3 style, well, V6 style hot end. Okay, I came across these Bambu Lab hot ends that have a removable heater block. I later found the same on AliExpress that are a lot cheaper, like $7 each. And the idea is to mount our own V6 style heat break to this cooling block. All we have to do is drill it out, tap some M7 thread in there and add a piece of Bowden tube. I think that it's important that as many people can do this mod, so I came up with a process that only requires basic tools. The 4mm hole can be drilled out directly, and I designed some guiding blocks to drill out the 6mm hole for the thread. There is an M4 screw in there that acts as a stopper, so you go to the right depth. The hole wasn't perfectly centered, but it's good enough for now. I also made a guiding block for tapping the hole to be able to tap it straight. 4mm is a bit too tight for the Bowden tube to fit, so it's better to use a 4.1mm drill or a 4mm chainsaw file to make the hole a bit bigger. Once the tube is pressed all the way in, don't worry, it stays in the cold zone so we can still crank up the printing temperature. You can cut it flush. The last step is to solder the connectors to it that I salvaged from the original hot end. Apparently it's not possible to solder to this heater wire, so I had to be a bit creative using ferrules where I removed the plastic part from. Some Kapton tape to prevent it from shorting out, and it's done. Running the wires is a bit tricky because of the limited space, but eventually I was able to mount it. The problem was that the fence route doesn't fit anymore, and because I want this mod to be reversible, I decided to use a ring heater instead. These are also easy to source, and this way I could also test my new longer guiding block. Because of that limited space, I had to remove the strain relief from the ring heater and file out a bit of material from the block to make space for the thicker wires. This way it's possible to route the wires the same way as the original hot end, and this package looks pretty legit. After mounting it, I found out that the nozzle wasn't touching the nozzle cleaner, so I unscrewed the heat break a bit further until it was low enough. Fortunately, the set screws on the side hold it in position and I was able to test if it works. I think that it's safe to say that we've got a world's first here. We managed to print with a 1.8mm nozzle. As far as I know, no one has done that before. You cannot buy a 1.8mm nozzle for the X1C. I think this proves that it works. If I would have kept this the way it is, then I think that I would have settled with this mod, to be honest. So yeah, that's pretty cool. This is an actual improvement, not like some experiment. It is an experiment, but it's pretty rare that I'm actually improving a printer here, so that's pretty epic. And now, with the super volcano, I thought that it would be funny to take this a step further by adding this monstrosity of this super volcano hot end. In order to make that work, I wanted to remove the plastic panel that would definitely collide with it, but, and this is a rare occasion, I made the right decision here. Sometimes it's better to just pick your battles. So if we want to get the super volcano working on this thing, then we have to get rid of this piece of plastic. But there is a lot more mounted to it than I expected. You have a module here and power supply, and I just don't think that it's worth it. So let's continue with the build, crack it open, see what other surprises we can expect. I think a printer is just stepper motors, a heater, 2 heaters, temperature sensor. So how hard can it be? If you get rid of the fan, then it won't be as noisy, and we have a way of mounting the board, because I can just make a bracket that fits with the fan and the board. Maybe this is even easier than I thought. I removed that fan, and this is the perfect spot for our board. I downloaded the reference models of both a 92mm fan and the board, so I could design a simple bracket for that. I got some temperature resistant PLA from Polymaker, which is perfect for this, and printed the bracket on a Prusa Core 1. I added some M3 nuts that hold the board and mounted the bracket to the printer using the original screws. I removed the motor wires from the original controller, and I could just plug them in her new board. For a second I was afraid that one cable was much shorter, but it was just folded up in there, and this was almost too good to be true. The next step was the heated bed, and I found the wire that I expected to be for the temperature sensor. To make sure that this was the case, I measured the resistance and was hoping for a value of around 120 kilo ohms, which it turned out to be, and means that we have a very standard temperature sensor here. I removed the cover from the power supply to find out how the bed heater was controlled and found this relay board. The bed heater runs at mains voltage, and this relay board is used to switch that at a low voltage. I only had to figure out which pins are used to control that relay, and it should work. Before placing back that cover, I made a power cable for our new control board. I crimped forks on one end of the cables and ferrules on the other end and mounted it to the power supply. We can just leave the original power cable because of the double terminals. I routed the wires, disconnected the power cable from the original board and powered it on to see if it works, which it does. Now I could place back that cover and connect the control wire for the heated bed. I realized that I bought this kit in my previous video where I modified the Creality K1, which has male and female pico blade connectors. This happens to be the exact connector we need, and this way we don't even have to modify our existing cables. I made the extension cable for controlling the bed heater, but ran into the problem where my ferrules were too big. Well, no one was watching, so please don't tell anyone. Now it's time for our temperature sensor, which is a 2-pole pico blade connector. This was a bit of fiddling with removing the strain relief and routing that extension wire correctly, but eventually this was also a very easy procedure where everything can be turned back to how it was if you wanted to. I realized that I didn't add a way of tying the wire to the bracket and came up with a temporary solution. I'll design this for later, but this does the trick just fine. I had to crimp very small terminals for the connector that goes on the new control board, but I don't have the right crimp tool for that. My motto is, it's better to have a decent solder job than a poor crimp job. Now it was time for probably the toughest part of this whole project. How to control that extruder. I removed all the covers and this was as complex as I was afraid of. I didn't know yet what to do and procrastinated this decision by removing another cover that needed to be removed for the control panel anyway. And realized that I overlooked one tiny screw. Do you see it? It's there. Let's forget that this happened and continue with that extruder. The problem is that this is controlled using some kind of protocol on probably a CAN bus. I can extend all the cables, but it will be hard to do this nicely. I started digging further and removed all the screws I could find until I could remove the whole extruder. Eventually I ended up with this. Could it? No. Could it fit an orbiter extruder? No way that this is gonna work. Well, it's looking pretty promising. So, instead of this complex pile of parts where I forgot most screw locations, this, the simplest extruder in existence. Alright, let's go with that. Let's remove that bracket. Remember, you don't have to do this. No one has. This is not fun and I have to do this so I can reverse engineer this part. I 3D scanned it to get a reference model. This is a black part, so I didn't expect a quality scan, but this way I can prevent making stupid mistakes like designing in a mirrored image and forgetting features. The next day I started reverse engineering this part in such a way that it has all the features so we can use it to design our own tool brackets for it. I imported reference models of everything that we are going to mount to it and things escalated a bit. Before the day ended, I printed it, melted in some brass inserts and tried to fit everything. I made notes of everything I had to change and continued this cycle until... Imagine, you've been following along with this project. With all the enthusiasm in the world, you ripped out that extruder only to find out that this was the only printer you have and you forgot to print the parts you need. Yeah, that's a bit of a problem. Well, a good solution would be to have someone else print it for you then, and PCBWay, the sponsor of this video, could help you with just that. I sent them the design files and wanted them to print it with the Jet Fusion technology, because this will result in a high quality lightweight part that would also fit with the aesthetic of the printer. I was very excited to unpack the parts and they came out as well as I hoped. They also added brass threaded inserts in there and some of them were really hard to reach. I only had to send a drawing pointing out which insert goes where, and the only thing I have to do now is putting it together. This is made to fit the standard Bambu Lab hot end and I'm using the one we just modified so we can replace the nozzle and keep the rest on there. PCBWay is known for making PCBs of course, but I really like the fact that they can also make parts like these, which is basically a finished product. You can even take it a step further and have them produce injection molded parts for you if you need a lot of them. Also, sheet metal fabrication is an option, which would be nice to explore one day. I designed my part in such a way that you can use the screws from the original extruder and all the cables can be tucked away nicely. It's really cool to see your own design like this, and thanks to PCBWay for making this possible. Check out my link in the description for more. Alright, we are back in time now. As we speak, PCBWay is making that bracket for the extruder. And you have already seen it if you watched the sponsored segment. I have no idea how it looks, so I'm very excited for those parts to arrive, which should be any day now. So I decided to focus on the mainboard and the display. My initial plan was to use the original display, but then I realized that I want to make this reversible, non-destructive. So I designed a display enclosure for it with an integrated friction hinge. And after a couple of attempts, It fit, everything fits now. I also started configuring the main board and decided to go with RepRap firmware. This is my go-to firmware. I use that to print the rims with for the Mercedes. I made a grill plate printer using that firmware, and also pretty recently, together with Ivan, we made this treadmill printer. So for me, RepRap is the way to go. Some of you might prefer Clipper. That's the beauty about this. You have choices now. I set the jumpers in such a way that we hopefully get sensorless homing to work, so we don't need those end switches. And I placed the stepper motor drivers. But I ran into issues with this Wi-Fi module. Long story short, you should follow this guide. Don't be me, don't skip steps and make assumptions. Just follow it by the letter and it should work and not be a very frustrating experience. So I got that working. I was able to connect to the board using the Duet interface. And I thought it was really cool that we were able to control the bed and read out the temperature with only using the extension wires that we made earlier. But I couldn't get this display working. It was reading out the temperature, but I couldn't control the board. So I initially thought it was because of the cable. That cable was pretty flimsy. So my plan was to use a stepper motor cable, but that's a 4-wire cable, while this is 5 wires. So I was very lucky that I found this display cable. I had to extend that cable anyway to be able to route it all the way to the front. I cut off the flimsy connector, soldered both wires together, and now I have this cable now, which is very secured. But it still didn't work. I also tried another display, which I happen to have. It's a TFT35 instead of the 50. This also didn't work. I was aware that you should upgrade the firmware on these things, but what I learned is that you shouldn't rename the bin file, just leave it as is, and then you can flash it, and it works. So, we've got a working display now. Ik krijg gewoon antwoord. Hele dag naar de tering. Maar ik heb het moeilijkste gehad. I had the hunch already, but we don't need these cables. This is only for Marlin. So with the RepRap we only need this cable, which makes things a lot easier here to route it. So the only thing we have to do now is further configuring that board with the sensorless homing and everything, and then we can put everything together. What I like about RepRap is how easy it is to configure it using the web interface, and the first thing I worked on is the sensorless homing. Normal homing is done using a micro switch, but with sensorless homing the board can detect the motor stalling. This needs to be tuned. When set too sensitive, it will stall the motor before reaching the endpoint, and when the sensitivity is too low, it will not detect it at all. Also, the amount of current to control the motors is a factor here, and after several attempts I got it working. Homing the Z-axis is done with the touch sensor. The sensor worked, but there was something not right with the Z motor. I thought I set everything correct, but decided to measure how far that axis actually moves, and then I realized that there is this ratio between the Z motor and the 3 lead screws. To determine that ratio, I figured out how many teeth the motor pulley has by measuring its diameter, and I had to count the number of teeth of the bigger pulleys. Once I figured out that ratio, I could modify the configuration file to match the steps per millimeter. Now everything works as it should. We've got ourselves a Bambu Lab X1C running on RepRap firmware now, which I think is pretty awesome. I managed to configure it so the whole sensorless homing works, the touch sensor works, and I have got this really cool looking package with the orbiter extruder and the custom hot end that we made earlier. So the only thing that we have to do now is extend all of this wiring and connect it, of course, mount everything, mount the display to the front. But there is a slight issue. This Bambu Lab fan is running at 5 volts. If you're going to connect it to the fan output of that board, then we will destroy it because that's 24 volts. You can buy a module for that. I wasn't able to get my hands on one of those modules. I did find one on Amazon I think it was Canada, but the price of that thing, it's... So if I look at how it's done, it's just a DC-DC converter. So I think that it would also work with just one of these standard DC-DC converters. A few bucks, easy to source. I just realized that this fan is running at 24 volts, I think. I think I will just place this DC-DC converter in between the fan output and this fan. Yeah, so we have 24 volt for one fan and 5 volts for the other. All right. I mounted the display in the enclosure, which is a satisfying assembly and only requires some standoffs and screws. It has an integrated friction hinge, and in order to make this run smoothly, M5 washers are used in between both parts. A lock nut is placed on the inside, so it won't come loose when adjusting the angle of the display, and it's mounted with regular M5 socket head screws. The friction hinge works really well, and this is a drop-in replacement of that original display. It's a bit of fiddling to get the cable through, but it just fits, and the original cable is just placed to the side. It's not in our way anyway. The display is mounted in a similar way as the original display, and now I could route that wire to the main board. I was extremely lucky because the length of that cable is absolutely perfect. I turned on the printer, and it's really funny to see the BigTreeTech logo appearing on this printer. The next step was to extend the cables of that extruder. This can also be done with a CAM module, so you only have one single cable running to the main board. But I'm going old-fashioned, just like how the old and the 3s are made. Finally, I added a cable sleeve to make it look sleeker. Mounting this to the original bracket is done using the original screws used to mount the original extruder. They cut their own thread into the 3D printed part, and this is working great. This was a good day. It was getting late, so I decided to call it and continue tomorrow morning.
Your shadow stretching on the floor while the sun gets low. I got a feeling that the glow deep inside my core needs to breathe to flow. We push it right on through. I know you need it too.
Honestly, I didn't really check it that well beforehand, and I got really lucky with the length of all the wires I used. I also removed that bracket I designed earlier because I designed one with integrated strain relief to make sure that this goes well with the bad wiring. I was feeling good and things went great, but it was too early for celebration. The fans were not running, but I eventually got 24 volts where I needed it to be. This was for the DC-DC converter that converts this to 5 volts for that small Bambu Lab fan. But after trying to adjust it, the printer suddenly reset and you can see the puff of smoke that came off the converter, which got fried. Luckily I had a different converter, which I was able to adjust to 5 volts, and I mounted that in there using double-sided tape and connected it directly to that small fan. After some more configuration, I got that fan running as well, and now it turns on when the nozzle temperature is above 45 degrees. The next step was to do mesh leveling, where it uses the touch probe to measure the bed surface. Once finished, it generates a height map, and mine showed that it was tilted sideways. It's best to have this as flat as possible so the software doesn't have to compensate as much during printing, and I used the old-fashioned piece of paper technique here. This generated a much better height map, and this is where I decided to put the printer back together. I didn't like the alignment of the display in its frame, so I measured how far it was off and thought that this would make for a great first print for this printer. The next day I modified the design and sliced it in Simplify 3D. Not that this is the best slicer, but I can use whatever slicer I want now. I placed a spool of matte PETG, raised the temperature and started extruding the filament. But nothing came out and I got this error. I initially thought that this was because of wrong wiring, but eventually, after several failed attempts, I looked at the documentation and found out that I connected the extruder motor to the second Z-axis output. This meant that the extruder moved together with the Z movement. So remember, if you mount back all panels, the single thing you didn't check will not work. I connected the motor to the right output this time and it worked. It was even going into the right direction, which for me is not a given. Yep, it finally extruded filament and I could start the print. I wasn't really happy with how it looked though, and it was also misaligned. I thought that it missed steps due to too high of an acceleration, but then I saw that the whole gantry got slanted when I homed the X-axis. Turned out that I forgot to fasten the screws on the back that holds the motor in place. This was an easy fix and I restarted the print. After a while it was finished and I tried to replace it, but it didn't fit. I didn't want to rush things, so I decided to dry this filament in the hope that this would help. I wanted to use that nozzle cleaner function, but the nozzle is a bit lower than the original was, so I designed a lower version of this part that is optimized to be 3D printed. I made two lengths so I could test which one fitted best, mounted the original PTFE tube to it and mounted it to the printer. The shorter version was a bit too short and the longer version really touched that nozzle. I also mounted the 0.4mm nozzle to it instead of the 0.6 I had on there and made a new start sequence that uses that nozzle cleaner now. This time the print came out much better, but it was still a really tight fit. So yeah, I had to use a small press to get the board in, just don't mention it. But the version I will share online with you will have a bigger tolerance. Well, this one fits now. Introducing the Proper X1 Carbon. With an articulating display that self-adjusts when opening the door. There aren't many fancy things going on, but it's really easy to control and its print quality can be formulated as decent. No more complex slider scanning, just a touch probe that, well, probes. However, this printer is made for printing carbon-filled filaments. It's right there, it's in the name after all. PLA with carbon, nylon with carbon, polycarbonate with carbon, other types of nylon with carbon, PET with carbon, PPS with carbon, more PPS with carbon, some random spools I had lying around with carbon, everything carbon. This is the material that the pros use. This is the technical high-performance stuff used by true engineers, because you are the engineer. Engineers are born to be able to destroy whatever they want, no restrictions, full control over the things they own, go further than limits set by others. Oh wait. This is where we have to push it further. Show your skills, show what you're worth, and make it work the way you want it to. Beyond the boundaries is where the excitement lies. This is where things can go wrong and where we start learning. You don't read instructions, let alone safety guidelines. You know it's not intended for this, but it's your intention to do this. And then you accidentally designed a precision ratcheting screwdriver that only requires some printed parts, bearings, screws and a simple rod. With a press-fitted bearing and utilizing a one-way clutch so there's no backlash and no rattle. Yes, this is the stuff I live for. Just making cool things myself and being able to do whatever I want to do with it. If things are worth doing, they are worth overdoing. I won't stop until something fails, and even then I will push it further. It needs to hurt in some way. I am the engineer and I will disassemble everything I want with the things I create and make it the way I see fit. Well, I made a screwdriver. Did I need to use PPSCF? Well, no, but just listen to the sound that this makes. So, there are some interesting features to it. There's no backlash and... Okay, if you want to see more of this screwdriver, just let me know. And it was just a joke, but this is honestly a pretty good screwdriver. Something else now. As you know, PCBWay sponsored this video by making these brackets for me out of this Jet Fusion technology, and they came out great. And I ordered 5 more with the idea to give them away. And I think it's important to give it to someone who is really interested. So the idea is that I'm going to make a post on Patreon, and if you're a Patreon supporter, you can leave a comment there below that post saying that you're interested. And after 2 weeks, I'm going to pick 5 lucky winners. You can be any Patreon tier. You can be one of these guys, these top tier Patreon supporters, or even a gold member. Special thanks to them. It helps a lot with these projects. But you can just choose whatever tier, and I will send 5 of these away.